So in this video, I'm going to explain the next subtraction instruction, which is called as a SBI. Subtract 8 bit of immediate data with borrow from the accumulator, and after performing this subtraction operation, store the result into the accumulator itself. So that is the reason it is given here. The meaning of SBI is subtract immediate with borrow. So first of all, we'll see their opcode. So their opcode is written here as a SBI, and their operand will be 8-bit data. Their operand will be 8-bit data, and first of all we will understand their operation first, then we'll see rest of the part. So let's say, for example, SBI 25H. So before execution of this instruction, let's consider here this accumulator contained as a 37H. This data, whatever it has mentioned here, that is 25H, and the status of the borrow, we can consider this here as a 1. So how it will store the result? So here what we'll do, this will be subtracting from the accumulator as a data and then with the borrow status. So what we can say, that ultimately it is performing from the accumulator. What is subtracting? If you take minus outside, then this is the data whatever it is having along with the borrow. So first this should be added together and then take their 2's complement. So this 2's complement will be added with A. So ultimately it is giving the result as a minus 8 bit of data along with this borrow. So here first of all we will see this data, it has given 25H. So how this can be written? So this can be written here as a data is equal to 25H. So this can be written in terms of binary as a 0 0 1 0, and then this 5 can be written 0 1 0 1, and their borrow status will be added here with their LSB. So now this will become here 1 plus 1 is 0, then 1 plus 0 it is 1, then again it is 1, again it is 0, then this is 0 1 0 0. So ultimately this result is 26H. So this data is 25H here, and if this borrow as a 1 it is added with this 25, it will become here 26H. So now take this 2's complement of this 26H. 2's complement of 26H, how it will be? So first of all, this 0 will be copying as it is, this 0. Then first non-zero 1 is this one, this is 1. And after this, all the bits will be altered from 1 to 0, 0 to 1. So rest of the bit we can write it here as a 0, then 1, 1, 0, 1, 1. So this is giving here the 2's complement of 26H, which should be added with the content of the accumulator. So here this accumulator content it has given as a 37H, which can be written in binary form as a 0 0 1 1. This is for 3. 7, how it can be written? 0 1 1. Now here we need to write 2's complement of 26H. So what is there? This 2's complement, we got it here as like 1 1 0 1, then 1 0 1 0. So now we need to add these two. So that is giving the result for this. So 1 plus 0, it will be 1 here. Then from the second stage, 1 plus 1, sum will be 0, carry will be 1. Then again from third stage, 1 plus 0, so sum will be 0 and carry bit will be 1. So in the fourth stage, 1 0 1, sum will be 0 and carry is 1 here. From the fifth stage, 1 plus 1, sum is 1, carry is 1. So from the sixth stage, 1 plus 0, sum will be 0 and carry will be 1. So again from this 7th stage, that 101 sum will be 0 and carry will be 1. So 101 sum will be 0 and carry will be 1 here. So as per the process I had explained earlier also, that whatever it is coming the carry status while doing this addition, this should be complemented as a final status, because here if you see that their MSB is 0. So MSB is 0, it means result is positive. So here this carry bit also should be altered. So it should be complemented. So complement carry, this is complement carry. So now this will become here, this 1 will change to 0. So we can write it here as a 0. Then this is the result which is contained by the accumulator. So here this result will be 0001, then 0001. So in terms of hex, it is called 11H. This is here 1. This is here 1. So 11H. So this is the result. This is the result stored into the accumulator. So here we can write that after execution of this instruction, what will be the content of this accumulator. So this accumulator will contain here as a 11H. Then this data, whatever it is here, it will be the part of this instruction. So now we have to check it for the status of their flag. So here sign bit, this is 0, their MSB is 0, so sign bit will be 0, and this result is non-zero because it is 11H. So this 0 flag will be reset here. Then we have to see it here as an auxiliary carry. So auxiliary carry is generated from this 4th stage. So that is here auxiliary carry status will be 1. Then we have to check it for the parity. So in this result, there are 2 ones. 2 ones means even number of ones. So this will be even parity. So this parity bit will be 1 here. And carry flag, as I told you that as a updation of the flag, whatever it is coming the carry at this point, we have to complement that. So that will be the final status of this carry after execution of this instruction. So carry bit will be 0 here. So why it is becoming 0? Because this MSB is 0, showing that result is coming here as a positive, so that this carry should not be 1 here, it should be complemented. So it should be reflected as like 0. So this is the status whatever we obtained after execution of this instruction. So as a note, what we can write it here? As a note, we can write that all the flags are modified to reflect subtraction operation. So not only few, all the flags as per the result, it must be modified here, as like whatever I had shown in this result, So now we need to talk about their size. So as I had mentioned previously for also, then here this SBI is the opcode along with this 8 bit of operand. So opcode will acquire one memory location of 8 bit storage, and this operand also will take another one more memory location with the 8 bit of size. So in terms of byte, we can say that before execution of this instruction in the memory, it will occupy 2 memory locations, each of size 8 bit or 1 byte. So their size will be here 2 byte. Now for the machine cycle, so first it will fetch this opcode and then it will fetch this operand. So this microprocessor, while execution of this instruction, it is going to access the memory chip 2 times. One is for the opcode fetch operation and another one is called as a memory read operation. So this will have 2 machine cycles, and this operation is called opcode fetch and memory read. So by default, as we know that for the opcode fetch it will take 4 T state, and for the memory read it will take another 3 t states, so total t states required will be 7 for the execution of this instruction. So here by this way you have understand about the opcode, operand, size, machine cycle, t state and their operation, how before taking this 2's complement this borrow status is added with the mentioned data as a 25h. So first this 25h or whatever it is the data, it should be added with this borrow. So borrow status, it might be 1 or 0 before execution of this. That processor is not knowing about that, but by default it will add this content and this borrow status, and after addition of these two values it will be subtracting from this accumulator content by the use of 2's complement method, and after that it is storing the result into the accumulator like this, and at the same time as per the subtraction it will modify all the flags as per the result obtained here. So by this way I hope you understand this instruction in the better way. Thank you.